Welcome! In this project, we will build our first graphical Python app that uses what we call a GUI, or Graphical User Interface. So instead of just some of the Python programs you would have done before would have just had text output, this one actually has its own window here, and it's got places you can input here, and the graphics come up on the screen here. And we're going to show you how to make a converter. So it could be a converter between kilometers and miles, or distance under the water and how many atmospheric pressures there are, or you could do something a lot more ridiculous, like my cat to llama weight conversion. So just to show you here, if I was to say 4 llamas and hit enter, it would say 4 llamas is roughly 160 cats. Or if I was to say 82 cats would be roughly 2.05 llamas. So have a think about what you would like your converter to be, whether it's a ridiculous one or whether it's a really useful or a scientific one, and then we will keep going from there. So to make the projects that we're coming up with in this next few projects, we'll be using something called CodeSculptor, which is an online Python environment. We can simply type in here CodeSculptor 3, and notice that's with a K, so CodeSculptor 3, CodeSculptor 3. And you can flick between the night version and the day light version, or the light and dark versions here. I like the dark version, but it's up to you which one you choose. Now, before we get started, I just want to explain a few things about this that you really need to know. Number one is there's no login to this website. Okay, so basically what happens is once you've done a little bit of work and you hit the save button, you'll notice that you just get an individual web address to your particular program up here. And what you should do is click on the star here, type in a name for your app and bookmark it so that it stays in your bookmarks bar. Alternatively, you could copy and paste that somewhere safe straight away onto your document that you're using to hand in for term 1. You could do that. But just be aware that if you don't save, or if you don't copy that link somewhere or save that link somewhere, you won't know, might not be able to get back to it. In an emergency, it might be in your history. You might be able to go back to it that way, but it's very important you save that, copy that link somewhere. The second thing to be aware of is that it does not auto-save. So if I make a change, it doesn't auto-save, and then whenever I hit save, which you should do often, you'll notice that the number here changes in the bar. So it'll go from 0 to 1 to 2. I'll just make that a bit bigger, to 2 to 3, 5, up to 596 if it needs to. All of your previous versions are also still there. So if you wanted to go back to the previous version, you can just change that number to one number before. So if you've made a big mistake and you want to go back, you can do it that way quite easily. So make sure that you hit save all the time and just understand how this works. You should remember what number you're up to at the end of the day and either update your bookmark, or just remember that when you go to your bookmark, you might need to change this to the latest number to get back to where you are. So it seems like a little bit of a weird system, but it has some real benefits because you don't need to sign in, and you can just hand this link in, whatever number you're up to when you finished, and go from there. Okay. All right, so I just want to explain a little bit about CodeSculptor. So CodeSculptor allows you to make programs with a graphical user interface. So this program here, you'll notice that the output here, if the output is for, if you say print, it'll print something in the output. But that's not the main function of CodeSculptor. If you hit run, the idea is that we're actually going to open up a window that will have your program in it. So for example here, we've got a button, click me, and I click on there and it says good job. That's the default code that's in here. But the main focus of your program is you're going to be building it in this window that comes up in this frame. The output here is mainly just for debugging. If you type print and you want to see what a value is, you can use it for debugging. Okay. Another thing I want you to understand is the library that we use for the graphics the simple GUI, is not the same library you'd use if you made a different application, Python application necessarily, because there are lots of different Python graphics libraries, okay? So the Python will be the same, the core language will be the same as the other projects you've done, but the specific graphics code things here like canvas.drawText, that's specific to CodeSculptor, okay? So don't feel like you have to memorize all of that stuff. The documentation here is actually really, really good. So you can look up, if you click on the documents here, you can look up in graphics modules all the things you need to do. So I want to add an image, I click on there. I can work out how to draw an image. If I click on, oops, there, all sorts of things that'll show you how to load an image, draw an image, whatever. And don't feel like you have to memorize all of this stuff as you go. All right, before we start, I just want to make a few changes to this template here. So let's delete this code because you don't need this code, those comments there. You can delete this because we won't be using that or that. Keep the draw function, that will run about 60 times a second, but you can delete this and you can just write pass because in Python you can't have an empty function. Get rid of the middle one here and then hit save. I just want to explain what the code that's already here means. Import simple GUI means we want to have access to being able to make a window, all of that functionality. So that's in simple GUI, simple graphical user interface. Then we've just made a function and called it draw. We could call it anything else we wanted, but that's a good name because it's the function that this function will get called 60 times a second and will draw stuff onto the screen here, okay? Now, that doesn't run at the start of the program, it just gets saved into memory because it's a function. But then here, this happens at the start of the program. This stuff all just happens once at the start of the program here. So basically, we make a new variable called frame, and we save it to be a new frame from simple GUI, and we have the name home here. So maybe we'll change this to converter, and the width and the height, let's do 500 wide and 400 vertically. So it makes that new window. It then sets the draw handler. Now the draw handler is simply the function that's going to run 60 times a second. I think it's 60 times a second, but repeatedly. And we set that to the draw function. So if this wasn't called draw, if it was called paint, for example, you'd have to write paint here, okay? Then the final thing we do is we actually start the frame. So when you hit run, all of this stuff gets implemented and this opens up. And you can see now it says converter and it's higher and wider, okay? I'm going to hit save again just to make sure, always save because it does not auto-save. We're just going to work out how to draw text onto the screen and we're going to get our heading onto the screen. So in my case, it's cat and llama weight converter, but in your case, it should be whatever you're going to call yours. And if you haven't decided, just put a placeholder name in there, something rough for the moment. So if you'll remember, the code that we've got so far, basically, you could ignore the draw handler for the moment, but basically it imports the simple GUI library, makes a new frame, sets the function that will run over and over again whenever the screen is ready to be drawn, sets that to our draw function, and then starts the frame. And at the moment, that just creates this. Now, I just want to explain how the system works for plotting points or putting something in a specific spot on the page. So it's 500 wide, so that means that the X value, when we place something on the page, on the left-hand side here will be 0, and on the right-hand side will be 500. Now it's 400 high, I believe, if that's correct, yes, that we've chosen for this project. So this will be, well actually you might think this is 0 and this is 400, but it's actually the other way around. This is 0 up the top and it's 400 down the bottom. So as you go down, that increases. So you can think of it a little bit like writing on a piece of page. It goes from left to right and top to bottom. Okay, and this is very, very common for a lot of different computer programming languages will set up, and a lot of GUI libraries, graphical user interface libraries, will set up the canvas like that. Okay, and we can call this a canvas. Okay, that we can draw on. So how do we get some text on the screen? Well, that's pretty straightforward. We can go to the docs here. Now the docs is short for documentation, and anything that you don't know how to do, it's like an instruction manual. Anything you don't know how to do in the GUI here, just go to graphics and it will tell you everything. So if you go to, it took me a while to find where the text was, but it's actually in the section called Canvas here, and you'll see that there are all of these different functions that we can use. We can draw lines, circles, arcs, polygons, points, images. Images is going to be useful to us later, but at the moment we basically just want to draw text. So I'm going to click on the draw text function, and you can see here it actually gives a very detailed overview of what everything means, and has an example of an entire program here that will draw some text for you. But basically what I'm going to do is I'm going to just copy, yeah, I'll do that. I'll just copy this syntax here, Control C, and then we'll go back to here. And where do I want to draw the text? I want this to happen in the draw function here. So we'll say canvas. Now it has to be in the draw function because every time the draw function runs, it actually clears the screen again, and it'll be overrun with whatever. So first thing is that text, and it's a string, so it has to be in quotation marks here. So I'm going to type in my string there, which will be cat to llama weight converter. Oops. There we go, cat to llama weight converter. And then the point here that we want to draw it at, if I remember from the documentation, was actually a tuple, but I will double check that. Yes, okay, so you can see here, you can either use a list for the X and the Y position, or you can use a tuple. So a list and a tuple are basically the same in Python, but a tuple can't be changed. You can't modify it, whereas a list you can modify. And that means that a tuple actually runs a little bit faster. It should be a bit more performant. Okay, so in here we put the point that we wanted. Now I want it up the top and over to the left. So just maybe 20 pixels in, just a little bit in from the left, and maybe 50 pixels down from the top. You can always adjust these later. The font size, I worked out already that I think 36 is a good size for mine. And as for the color, you can go to the internet and paste inside these quotation marks a hex color. So you could go to Color Picker if you Google Color Picker, and you could put in, well actually, let's do it. I'll show you two different ways. One way is you can just type in white like that, and you'll see it just comes out as white. And I'm going to hit save because every time you do something, if you don't hit save, you could lose it. So just be careful. The other thing you can do is to go onto the internet and get a color. Let's do that. So we're here, we can just type in Color Picker. Okay, and let's say I wanted it to actually be like a really, maybe like a light yellow or something. Okay, so I'll go up here, and I should be able to just copy this color here and paste it instead of the word white here, because there are only a limited number of color names on here. They're in the documentation too. And as you can see, now it is that particular color. I'm going to show you how to get the pictures of your two different items you're going to be converting between up on the screen. Mine's going to be a cat and a llama. Yours obviously doesn't have to be a cat or a llama. Like I said, it might be an image for kilograms, or it might be whatever it is that you're converting between. Two different currencies, completely up to you, okay? Now, I should warn you that getting an image up on the screen in CodeSculptor actually is a little bit tricky. So bear with us, and if it's not working, keep playing around with it and I can help you as well. I'm going to show you how to get the first one on there, and then I'll leave it up to you to copy that to get the second image up there as well. All right, let's get into it. I'm going to head over to Google and type in cat and go to an image search. And I'm going to try and find myself a picture that is reasonably sort of squarish. And I may end up using a different picture than the one I show you here. I might take quite a bit of time and have a think about it, but I think actually, no, there's the one I used before. I'm quite happy with that. So I've clicked on it. If I right click on it and say copy image address, and just to make sure that that works, I can paste that into another tab up here, and yes, you'll see if it ends in JPEG or PNG, you're in luck. Sometimes there are different formats that CodeSculptor might not support. But anyway, that's the one that that I'm going to choose. Now, a couple of things before we start. Just be aware, as I'm hovering over here, can you see that it says the dimensions down here? It says 1200 times 1199. That means that it's 1200 pixels wide and 1199 pixels up. That's going to be important when we're drawing it onto the screen, okay? In fact, I'm going to paste that into Paint just so that I can show you in a little bit more detail what's going on in a minute when we draw the picture. So to get the picture on the screen, there are two steps. One is we have to load the image. The next is we have to draw the image. So we'll load the image up the top after we've imported things. And the way that we do that is we need a variable name. So I'm just going to call this cat image, but you can call yours whatever makes sense for you. Cat image equals, and then we have to call simple GUI dot load image like that. That is a function that will get us an image loaded. And inside the brackets here, we need some talking marks and then or quotation marks, and inside that the string of the the string of the address here. So remember, right click, save, copy, sorry, copy image address, and Control V, paste into there. Okay, so that loads the image at the start of the program. But then what we want is in our draw function here, we want to draw this. Now we want to draw it down here, and so there is actually a function. If you go into the docs and go to the graphics modules and canvas, there's a draw image. Okay, so we've already done the thing here. You can see it's got load image, but to actually draw the image, we want this here. Okay, I'm actually going to take the example here so you can see. Okay, so we need canvas.drawImage. The image will be the name, and then it's got all this weird thing here like center source, width height source, center dest, width height destination. And what I'm going to do, because this is a bit complicated, is I'm actually going to show you my final code. And I'm going to explain what each number means. Okay, so here is the final code. So we have canvas.drawImage. Cat image is simply the variable name where we've stored our loaded image. And then we have this tuple, which is two numbers, and we'll explain why there's a division in a minute. There's another two numbers, there's another two numbers, and another two numbers. And I'm going to explain one by one what these are. I'm actually going to start with this one. This is actually just asking you for the width and the height of the image that you're going to draw. Now, if you remember, if you hover over the image down on the right-hand side, it'll actually tell you the width and the height down there of your image. And in fact, you don't have to use the full width and height of the image. Let's say, if I get a different color here, let's say if I only wanted to draw this portion, okay, instead of saying 1200 for the width, I could say 600 or 700, and the same for this. So you can actually enter numbers that are smaller than the original width, but it just means that it won't draw the whole picture, if that makes sense. Now the second number asks where you want the center to be. Now we want the center to be if I put a brush here, we want the center here to actually be smack bang in the middle. However, again, let's say that you didn't, let's say you wanted to draw a part of the image like this, you could specify that the center is somewhere else. But we're going to keep it very simple. So where is the center of 1200? Well, it's just 1200 divided by 2. Where's the center of 1199? It's just that divided by 2. So if you go back and look at our code, you'll in fact see that we've just put 1200 and those, but your numbers will be different. Just go look on Google for the one that you chose, the picture you chose. And the same thing here, just divided by 2 for the center position. And just a reminder of a few programming things. So these normal brackets instead of the square ones is a tuple. It's just like a list, but it can't be sort of modified on the next line, for example. You couldn't change one part of it or something, but we don't need to in this case. Why? You're probably wondering why there are 2 lines here. So a single line like that is normal division, but in Python 2 lines is what we call integer division, which means that here if there's a decimal, the decimal will get thrown away. And that's good because with this draw image, I think we're meant to put in an integer or a whole number. So it'll just make sure the answer is a whole number with no remainder, okay? Okay, so this is the center of the image. This is the whole image. Now, these ones here are a little bit different. Again, I'm going to start with the second one out of these two. So this is actually how wide and how high we want the image to be drawn on the canvas. So right now we've got 150 pixels wide, 150 pixels high. But if I was to change that to 15 by 15, you'll see that it's going to be absolutely tiny. So that's just on the destination canvas, how wide and how high it is. Okay, so this one is what are the dimensions of the image you want to draw. This is what are the dimensions of how big you want on the canvas. Same thing here. This one was where is the center on the image that you are bringing in, that you're loading. This one is like where do you want it centered on the canvas. Okay, so if I was to put this as 0, 0, that would be in the top left corner. It would be centered in the top left corner. But I don't want that. I want mine put around about there, because I'm going to have another image next to it, okay? All right, so hopefully that all made sense. Having seen that, I'll just reset here. Yep, having seen that, I think what I would really like you guys to do is to try and load your second image as well, and then copy and paste this code and change the link, give it a different name, and then you can copy and paste this line of code and try and get the numbers right for your second one as well. And then hopefully you'll have both of them on here. So far we have our heading here and our 2 images, which is pretty good, but we need to have 2 fields up here that we can actually enter numbers into and some text as well. So what that's going to look like is we'll have a sentence here that says to convert, fill in one of the boxes below, then press enter. And then we'll have the label cats, an input field, the label llamas, and an input field. All right, let's get stuck in. You'll notice that in our code we have this section here where we create the frame and we set the draw handler. This is the section that we should add anything that's going to be a feature of our program, like labels or input boxes. How do we know what to type exactly? Well, we can go to the docs section again, and our graphics library is in this tab, the graphics modules. And we can go to the canvas. I think it's canvas. Let me check if it's in here. No, I think we actually want control objects. So control objects must be the things that we put on the left, like the buttons and the labels. So we want to add a label. So I'm going to click on that. And it says here that you can say add a label and then the text. So I'm just going to copy that, Control C. And I can put it here. Control V, and in that I'm going to type, I'm just going to copy this from, my other project. So it needs to be in quotation marks. And you'll notice here that when we run it, oops, what's it saying wrong? Bad input. I accidentally put an extra bracket there. Okay, so you'll see here that it says to convert, fill in one of the boxes below, then press enter. Now you'll notice here that I wanted it to have talking marks around enter. So on the actual, sorry, I just realized I still have a print statement from before. I'll get rid of that. You won't have that. That was when I was messing around with it. So you'll notice here that when we, because I wanted to put talking marks around the word enter, I actually used double quotation marks around the whole string so that Python didn't get confused. If I wanted to put double quotation marks around enter, I could have put single quotation marks around the whole string. But if I'd used double quotation marks here, it would have thought that I was ending the string, and that would have been really confusing to it. Okay, so we've added our label. I'm going to add a couple more labels off the screen, and I'll show you afterwards. Okay, so you see I went and looked in the documentation, and sorry, I said label before, but what I meant was an input field. So I've added a couple of input fields. So the label is, hold on. Oh, we can't run it yet. I'll explain why in a second. But the label is the text up there, and then we have two boxes where we can enter the number of cats or the number of llamas. Okay. Now the reason we can't run it yet is because we don't just put the name of the input here. We also have to put the name of the function that gets called when someone types something in and presses enter. So let's make those functions now. We're going to make a function def called cats entered. Now you should probably, oops. Okay, I'm just saying pass for the moment, and I'll do the same with llamas entered. But you should choose a name for your function that makes more sense for your particular context. So pass we just put because you can't have an empty function in Python. Okay, you'll see here that I've got a field here that says cats, and I can type something. Now, when I type something in there and then I hit the enter key, the moment that I hit that enter key, it's going to run this function called cats entered, or whatever it is that you've called. So we have to have a think in a minute about what we want to happen when that happens, when we enter some text in and hit enter. What do we want to get triggered? Okay. The 50 here is just the width of it. So if I was to say 100, you'll see that that's a lot wider. So you'll have to decide how wide you think you need it, but I don't think we need it that wide. Okay, so now we've added the input boxes. What do we actually want to happen when when somebody presses enter? Well, I reckon in this video what we'll do is we'll just start with something very, very simple. So this, whatever you type in here, I've just put txt for text. So that's the text that's coming in. But basically, you could name that anything that you like, but basically that is the variable that you'll be able to access in this function of what was the text that was entered by the user. Okay, so if I just said print the text and do the same for this one, print text, then when we run our program, if I put hi in there and hit enter, you'll see it prints it out in the output over there. Okay. Now, if we wanted to do a little bit of mathematics with it, we can't do that directly because it's actually a string that's come in. So, for example, if I wanted to double it, if I made a new variable called double or dbl, I couldn't just say it equals text times 2. I'd have to change it from a string into a number. Now, there are two types of numbers in Python. There's an integer, which is whole numbers, and there's floats, which are like decimal numbers with decimal places. And I probably want decimal places in mine. So I'm going to type float and put the text in there, and that'll change it to a float number, times it by 2, and then I'm just going to say print double. So now, hopefully, if in the cats entered, if we enter 4.2, it'll print 8.4, for example. Let's try that. So 4.2, oops, hit enter, and it's printed 8.4 over there. So I hope you start to get the idea of how this works. When I put in, for example, 72 cats and hit enter, I'd like to get it to calculate how many llamas that is. At the moment, remember our last lesson, we just got it to double it, so it's not 144, but how many is it? So obviously your project will be very different like this. You'll have to work out the ratio between your two elements, but I'm going to try and work out the ratio between my two. So I'm Google here and I can say, how much does a cat weigh? Now this is obviously all cats are going to weigh different amounts, but it says here roughly between 4 to 4.5 kilograms, okay? How much does a llama weigh? Oops. Okay, so it says somewhere between 130 kilos to 200 kilos. So I'm going to say somewhere in the middle, maybe 160. So if we say that 160 for the llama, and we divide that by, 160 for the llama, and we divide that by 4 kilos for a cat, and hit enter, that means a llama's about 40 times larger than a cat. Okay, so I'm going to make a note of that in my program. I can put a comment in here with a hash symbol, and I can say note, llamas weigh roughly 40 times more than a cat. So you'll need to get the ratio for yours. Obviously, if you're doing something like kilometers to miles, you can just look that up quite easily, 1.6 something, whatever it is. But that's my ratio, okay? So what we want now then is when we enter a certain number of cats, we need to work out how many llamas that is. And when we enter a certain number of llamas, we need to work out how many cats that is. And for the moment, I'm just going to print it out to the output console here, okay? So when llamas are entered, let's say, let's make a variable called cats. And at the moment, this is just living inside this function. So we'll say cats equals, okay, well actually, first of all, we'll make a function called llamas. Llamas equals whatever the text is, because if they enter the number 3 for 3 llamas, it's going to be a text 3. So we need to convert that to a float. So we'll say float of whatever the user input is. Actually, I might just make this really obvious in mine. You don't have to do this. But I'm just going to say user input. Because text is a little bit, yeah. And I'll get rid of this for the moment. Okay, so llamas is whatever the user input is, we change that into a float. But how many cats is that? Cats equals, so let's think about this. Llamas are bigger, so if there were 2 llamas, it would be 2 times 40 would be 80 cats, okay? So it's the generalization of that is cats equals whatever llamas is times 40, okay? Because the number of cats is going to be larger than the equal weight in llamas. Llamas times 40, okay? And then let's just print cats. Actually, let's print, we'll just print cats for the moment. Okay, so let's do the same up here. So cats is easy. It's going to be the float of the user input. Okay, how many llamas is going to be the other way around. So instead of times, it's going to be divide. So it'll be cats divided by 40. And then let's print llamas. Okay, let's test and see if that works, if we're happy with that. So if I run here, if I say 3 llamas, that should be 3 times 40 should be 120. And you can see 120 has come up there, okay? Now I'll delete that, I'll go into here. Let's do 50 cats. And so that 40 cats is a llama. So it'll be another 10, so it should be 1.25, hopefully. There we go, 1.25. So we know that that's working now, okay? So we've got our conversion mathematics working. The next step is to actually get that appearing here as text and a few other little things to tidy up. We're going to be tidying it up a little bit. A few things. Number one is if I enter 45 cats and hit enter, I actually want the number 45 here to disappear so that it's not confusing if I make further selections. And I also want the conversions to come up here as text. So let's get into it. So instead of printing the number of llamas and the number of cats, what I want to do is in the draw function, draw them out to the screen. And so I'm going to make a couple of global variables here, up the top here, and I'm going to make the cats variable, I'll just set it to 0 at the start, and the llamas variable, and I'll set it to 0. And then in the program here, instead of it creating its own temporary variables, I want these functions to use the global variables, okay? And the way that I do that is I say global cats llamas, and both of those then, instead of making new variables that just live in the scope of this function, it will go and fetch the global variables, okay? And we'll do the same here. I could have copied and pasted that, but that's okay. Okay. So hopefully that's working. So now we should be able to access these global variables in the draw function and draw them onto the screen. And the way that we can do that is I'll put a new comment here, and I'll just say something like draw results. Okay. And this one, maybe we'll tidy this up a bit and call this draw images. And this one, maybe draw heading. You don't have to do this, obviously. These are just comments to make the code a little bit neater, but it does help. So how are we going to draw the results? I'm just going to copy and paste this text and change some numbers. And in fact, I'm going to do that whilst it's paused, and I'll explain afterwards. Okay, so you can see here that we have 2 draw calls to draw text, and then when we hit run, you'll see they appear here, and if I say 4 cats, that's 0.1 llamas, for example. And basically, what I've done here is because we're drawing text and not a number, remember cats and llamas are actually floats, and so they're not text. And the way that we convert them into a string is to write str and then put brackets. So those are the things that we're drawing. These in a list, or again, I could have used a tuple like this. That might be a little bit more efficient for the program. So this is the X position and the Y position. You can have a play around with that. This is the font size, and this is the color. So we'll check that again, and we'll say 7 llamas equals 280 cats. Okay. Now I'm noticing they're a bit on the left-hand side here. I might just move them across to the right a little bit. So instead of 50, maybe we'll do 70 and 270, and just move them over a little bit. But you can have a play with that. Now the final thing that I want to do here is I would like to have it so that if I type in 34 cats and hit enter, this actually gets removed out of here. And in order to remove it, we need to get access to that input. So where we make the 2 inputs, we actually have to save them in a variable, a little bit like when we did the load simple GUI.load image. We saved it in a variable. We call it a handle to it, so we can access it later. So the same thing here. So this one here, I'm just going to call C input, so short for cat input, or C inp. And this one I'm going to call L inp. I'm being a bit lazy there with the variable names. But that means that we can now access it from other parts of the program. So what we can do is here, where it says cats entered or llamas entered, we can get access to those. Actually, we probably don't need to get access to them because we're just, oh no, we do need to do that. So I will put that there. Yep. So C input, L input, Now we have access to actually modifying those fields when these functions run. I'll put this here too. Okay, and what we can do, I'm just checking my other project here because be honest, I have forgotten. Oh, okay. I'm going to just copy and across this and I'll explain it. Okay, so I'm going to put a comment here and just call this tidy up and paste this. Okay, so what this basically does is I've said for both of the inputs, when you press enter, because that's when this function runs, do the llama calculations and the cat calculations, but then cinput.setText, and then I've got nothing. So it's going to set it to empty text. And we'll do the same thing in this function over here. And I'll show you what that will do when I'll hit save, but then when we hit run, that means if I put 43 and I hit enter, it gets deleted up here. And in fact, if I still had something in the other one, they both get deleted as well. Okay, so that just makes it a little bit nicer. And we are pretty much finished. The only thing I'd like to do is maybe set a different background color. And the way that you do that is down here. I'm just going to say set canvas background, and I've chosen a color there, and that's looking a little bit better. But you choose whichever color you like and go onto Google Color Picker and have a look through. Test your program out a little bit, make sure it is actually giving you the accurate results. Make sure that you hit save here. Have fun.